In this video, we're going to be going over secants and what they are, and the problems that you'll be facing with them, as well as tangents. The first theorem I want to show you is on page 687 in your textbook. Let's see, right there. Here it says if two secants or chords intersect in the interior of a circle, and secants are lines that intersect a circle in exactly 2 points. Then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So let's see if we can make sense of that. You can look on that page. That's on page 687 again, if you want to look back on that. So for number one, I'm going to do, there's 10 questions on this worksheet. I'll do 5 of them with you. Number one, the intercepted arcs that they give me is 146 and 56. What that theorem just told me is that these angles here are going to have to be congruent to each other, because these two are vertical angles. But it's this angle is not 56 and this angle is not 146. I will need to add 56 and 146 together and find the average of those. So I'm going to add 56 plus 146 together, and that ends up being, is that 212? And I'm going to divide that 212 by 2, and I get 106. That 106 is this angle, and then it's also this angle up here. But that's not the angle they're asking for. Angle 1 is supplementary to both of these angles. So I would take 180 and subtract 106 to figure out what that is. And so this is going to be 74 degrees up here. Alright, I'll go through number 3. Number 3 looks a little bit different. We don't have two secants. We've got one secant right here. And this is a tangent line. Now, the tangent lines back in the last lesson, they said if a tangent shows up, then you're going to have a right angle if there's a radius that exists that touches that tangent, then you'd have a right angle. This is not that theorem. This is going to be a little bit different. This theorem shows up on page 688. Let's see if I can get just looking at it. This theorem shows up right here. And if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So, kind of like the same thing as inscribed angles. Inscribed angles were the angles that were formed with the vertex on the circle. That's what I kind of think of for these as well. So this angle that's formed right here, angle 3, is going to be half of this arc measure right here. They don't give me that arc measure, they give me this one. But each of these arcs, this arc and this arc, added up together has to be 360. So because they give me this one at 216, I can subtract 216 away from 360, and what do we end up having? 144 is what I get. So that's what this arc measure is. And that's not what they're asking for. They're asking for angle 3 here. So what we just read from the theorem in the book was that this is angle 3 is going to be half of this arc measure. So that comes out to being 72 degrees. Number 3. Okay. Now moving on to number 5. Number 5, again, it's going to be a different theorem this time as well. Now we've got two secants, but the point that's created by these two secants, they actually intercept outside of the circle. So, that's not a good enough picture right here. Okay. So, if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay, so each one of these, in order to find angle A in each one of these examples, in order to find angle A, you would take the larger arc here in red and subtract the smaller arc that's intercepted, the one in kind of light blue. We're finding the differences between the intercepted arcs. And after we find the difference between those two, we divide that by 2 or times it by 1/2, and that gives us the angle that exists outside of the circle. So let's see if we can put that to the test here. So number 5, they're asking for arc measure GJ. So I'm looking for this guy right here. They give me the angle out here, the 15 degrees, and then also this intercepted angle here, this 59 degrees. So our equation, in order to solve this angle, we already know what it is, so we can actually set it equal to 15 degrees. That was 1/2 of the difference between 59 minus GJ here. So we were trying to find out what this angle is going to be. You could just leave this as X instead if this kind of freaks you out. It's just, this is the unknown that we're trying to figure out. So we only leave it as X. But this X, this is the GJ that we're trying to find. So in order to solve this, we're trying to figure out this X inside. It's in the parentheses, and right now the 1/2 is affecting that parentheses. So I can times both sides by 2 to get rid of that fraction. So that's exactly what I'm going to do. I'm going to times both sides by 2. And so this side will become 30 equals 59 minus X. Okay, and we can subtract 59 from both sides. And this becomes negative 29 equals a negative X, and then times both sides by -1, and we get 29 equals X. Or the arc measure of GJ. So that's how we do it in that case. Notice the X was this guy. It's the same equation that was in the book on page 689. So you can reference page 689. Let me just put that up here, page 689. And you'll use page 689 for each of these as well. So I'm moving up here a little bit, 2 more. Here in this case, we're looking for angle Y. So here we would take, just like it was written before, the larger arc, subtract the smaller arc, and divide by 2. So I'm going to take 105 minus 63, and let's say I'm finding 1/2 of that, and that's going to equal angle Y here. So 105 minus 63 comes out to being 42. So then I'll have half of 42 is Y, and that comes out as 21. So Y is going to be 21 degrees. Okay, and number 9. Looking at number 9, we've got, they're actually looking for the measure of YAB. YAB. So we're looking at this whole arc measure here, where this touches all of this. So this would be the bigger arc here, right? All they tell me is that this angle is 37 degrees. So if I were just to set it up like we had before, we would have 2 unknowns, because I don't know what this is either, right? So if I were to set it up, I would say 37 has got to be equal to 1/2 of YB, or sorry, YAB, we'll say the arc measure of YAB, minus YB. Now, I don't know what either one of these are, so this is 2 unknowns on one equation. I don't have enough information to do this. Except that I do know that these two, because they're just 2 arc measures, these two have to add up to 360 degrees. So that's important to know. I also know that if I find the difference between these two, that difference multiplied by 2 is going to give me 37 degrees. So I'm still going to set this up just like it is. I'm going to times 37 by 2 to figure out what the difference is between these two. So if I multiply 37 by 2, I get 74. So I could say 74, let me write this a little, I'll write this under here. I can say 74 equals YAB, arc YAB, minus arc YB. Now why this sets up a little bit easier is because I know that the difference between these two has to be 74. I know the difference between these two has to be 74. I also know that when I add them up, they have to equal 360. So that is actually enough information that I can figure out what these two are going to be. You could set up a systems of equation, something like this. I know that if I just label this guy as x, this guy as y, I know that 74 equals x minus y, and I also know that if I add them together, that they have to add up to 360. So we've got a little systems of equation here. We could do a process of elimination, so we could actually add these two up, or we could do substitution or something like that. But the y's, this one sets up really nicely because the y's go away, and I can add 74 and 360 together and get 434, and that's going to equal 2x, and x was my larger angle. Divide by 2, and I get 217 equals x, which was my bigger angle here. So that's my answer. A little trickier. You'll have to do that with number 8 as well, and but good luck.